Hi everybody, Dr. Pingle here. I am going to try to demonstrate how to post-process data that you might have collected with an MLID reach. When you collect your data, you set up a project and it might look something like this. You've got an ntrip server providing your corrections. You're logging your data to the RINEX format, and then you run your project. I've got this configured to only take RTK points to only take RTK fix points. And you can see that we've got a fix right here. To do it for a 10-second average for my pole is 2 meters tall, and then you can see that we've got a good estimate of our precision down here. So we're at 1.4 centimeters on the horizontal and 1 on the vertical. We've got 27 satellites. So this is an okay, pretty good level of precision. Once you complete your project, you typically export the data off of the device. So you would export this as a CSV file and then a shape file with your the global coordinate system. So that's what I've done here. We've got a CSV file, and if we open that, I guess you can see that over here. So you don't really need a text editor. It looks something like, well, maybe we do. It looks something like this. So I'm opening this. This is a CSV file, so you actually could open this in Excel. I always prefer to open this stuff in a text editor. If you can, turn word wrap off, and you can see the information that we've got up here. The things that we care about are longitude and latitude. We've got a bunch of blank columns here. So this is our longitude and our latitude and our elevation. What those are referenced to is what this is, what your correction station is broadcasting in. So in that case, this is an ellipsoidal height for NAD 83 2011. You can see the precision, and the thing you kind of want to pay attention to, we've got an estimate of the height of our pole, which is the 2 meters plus 0.134 meters of offset, because our antenna is just a little bit above the base of the unit. When we took the points, so these were all collected around about 9:30 in the morning on September 18th. We have fixes for all of these, so that's the highest level of accuracy, and then some other information off to the side. We can close that out. We've got a shapefile that we exported that's actually all that same information. So we can extract all of that and get it here. And then, of course, we can drag this data into ArcGIS. So here are our points around. Remember that this is going to default to the projection of the data that came in. We can do the same thing with the CSV file. So we can drag that in there. That, of course, comes in as a table, but we can create points from that table, and we just need to declare the coordinate system that the data is in. Now, for casual GIS use, there isn't a lot of difference between the WGS 84 and NAD 83. But for high precision stuff, it matters a lot. Around this area, those are going to be off by over a meter. And so you really want to make sure that you get this right. So you want to declare this as a NAD 83 2011, not WGS 84. So then you can hit OK. I'm not going to pay any attention to the Z field at the moment, although this does actually matter. So we'll hit OK. And now our data has come in. And now you can start to see that we do have this difference between our WGS 84 values and our NAD 83. And in fact, the shapefile that we brought in has the wrong coordinate system attached to it. So we want to define the projection to repair it. So we can take our old Johnson service covers. This is the shape file that we brought in at first, and then just set this to NAD 83 2011. What that should do is snap those points back. These should now all be in the right projection, the coordinate system, I should say. We want to change our projection so that we're not looking at this as WGS84. We'll change it back to the Web Mercator, which is conformally relatively correct. And we will take a look at a base map, an imagery layer. So the Bing imagery is a little coarse for our use. It's not terrible, but if we zoom in here, we can see that we're reasonably well lined up on what are the service covers here. We can turn on the imagery layer, which I think is just a little bit sharper. So we can zoom in on this and see that we're hitting those marks pretty well. This imagery isn't quite as clear as we'd like. Relatively good results. We're more or less lining up here. Do keep in mind that your base map imagery is not always going to itself be aligned, and how this is handled. There's a lot of detail work on their end to get base maps to line up perfectly right. Google Maps is often one of the best, so we can actually add that as a path. You can look up this string, but we can add it, and we'll get a nice base map layer once that talks to the server. All right, so there's the Google Maps imagery, and just a little bit sharper than the others. Now you can sort of really clearly see the service covers here. Missing a few. Here we go. Symbology here is a little weak, so let's turn. We don't need this anymore, actually. And we can let's turn this to something a little more prominent. And as we zoom in, you can start to see that these are reasonably well aligned. I wouldn't say that these are again accurate to this imagery to any more than the radius of a service cover, which is maybe less than a foot. But at that point, we don't know whether this error is what the source of that error is. More than likely, the coordinates that we've got are correct, and the base map is a little bit off. The best way to make sure that your data is aligned is to reference everything to an opus correction. That's not a topic for this video. But this is relatively good. What I did want to talk about was running your data in PPK. So if we take the data that we gathered, which is the CSV file that we've got, that's one part of what we need. We also need the log file data. So when this records to a log, you can download those logs and email them to yourself or send them to Google Drive or whatever. Those come packaged in a zip file, so you would extract those back out. And then if you go into that directory, there's kind of a lot going on here. None of this in the first layer is actually what you're looking for. We've got a UBX file, which actually would do the job. We've got a base file. And we've got a solution file, but what you really want is the RINEX 303 file. So this is actually the data coming off of whatever you used for your RTK corrections. So in this case, it's NYBH, the Binghamton station. When it receives those corrections, if you have this set in your logs, it will record those corrections that it's getting in, which is what it's done. We can go in here. These are the actual RINEX files, and the data that you want are in this O file. At least that's part of it. The other piece that you want is the data that's in the P file. These are basically really detailed logs about what came in. We can actually open one of these up. This was only for about a 15-minute session. and yet we've generated about 20 megabytes worth of data. And the reason it's so big is that all of the stuff is actually recorded in plain text. So it's not a binary file, it's a plain text file. It's recording a lot of data, a bunch of data every second for all of the satellites that it sees, and that's why it kind of gets relatively large. But it is very robust, which is one of the advantages. So what you want to do, this is your rover file. This is the RENX file that's connected to the GPS that we took around with us to measure those points. And so this O file is what goes into the RENX. The navigation file is this P file that you want. This used to be named with an NAV extension, which made it a little bit more obvious, but this is the file that you want. And then the base file is the file that you're getting from the correction. So if we go back to our main data pile and look in that unzipped folder, this base file actually would do that job. We could drag this in here. We were receiving RTK corrections the whole time, and so we could actually use this file. I'm not going to do that. We could drag it in there. What I'm going to do is use one of these two files that I've downloaded. So this is data that comes from the NYBH CORS station. The date on this is 2024. This is September 18th. This is my station, NYBH. The format of this is always very consistent, so this is the easiest way to browse that data. Because I'm looking at data, so this is all in UTC time. I'm recording this in Eastern time, so we are 4 hours behind UTC time. So this is midnight UTC time. The B is 1 to 2 in the morning, 2 to 3 in the morning, 3 to 4 in the morning, and so on, all the way down. So if you get to, we did this between 9 and 10 o'clock. 9 plus 4 is 13, so 1 p.m. So we would be looking for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I think it actually ends up being N, if I remember right. Dragged it the wrong way. And then down at the bottom, because we're recording this at 9:15 p.m., this is, UTC midnight would have been at 8 p.m. here. So we're a little bit past that. So all of these hourly logs, once the day is through, get aggregated together in a larger file that you'll see down at the bottom. So these are all relatively small, 452K, 448K. All of those get aggregated together in this daily file, which is right here. It's this 12 megabyte file. So I've downloaded actually both the hourly and the daily. So this is the hourly and this is the daily, and either of these would work. If you can get the hourly, or sorry, if you can get the daily, this tends to be a little bit nicer, only because you don't have to worry about messing up your UTC conversion. If you got the whole day, then you're good. So here's that New York station for the whole day. You drag it into the base station here, and you get a result. Now it's going to read this data. It's going to read its ellipsoidal height there. So we know we're all correct, and then we just hit process. So what it's going to do is it's going to compare that GPS data that we logged while we were taking our GPS around. It was logging the whole time. I took a bunch of points, but these are separate than the points that I took. This is just sort of the raw track, once per second or so of the GPS as I took it around. What I need to do next, and I'll mention here that I've probably glossed over this, but this is the stop and go with MLID flow, which is what I always use in here. So it defaulted to that, but you'll need to make sure that you're in stop and go with MLID flow if you couldn't get that working. The next thing that we need is that project from MLID flow, and so if we go back to our data directory here, it's this CSV file that it's looking for. Now what's in the CSV file that it needs are the times at which this was taken. So you can see that in here we've got UTC times at which the point was started and which time it was stopped, right? All of these are 10-second grabs effectively. So what we need to do is drag this in here, and ordinarily you would really just want fixes. Now on this particular track, even though all of the points that I took were fixes as I was taking them, we've got a bit of an unusual circumstance in that they aren't fixes now. You can see that 93% of the track are floats and only 1.6 of them are fixes. And as I was taking this around, I mean, I would ballpark guess that 80% of the time it was in a fixed state. So PPK generally provides better accuracy, but not always, and this is one of those unusual cases where it's not going to. We almost never want single, unless you're very desperate, but fixes are generally accurate on the order of 1-ish centimeter. 1 to 5 is kind of what I tell people, but it's often between 1 and 2. Floats are somewhere on the order of a ½ meter. This is usually too bad for what I'm looking for, but today we'll take it. So we'll just hit start, and we'll get the points that we took. So I took a number of these sort of surface cover points as I walked around the old Johnson building, and this is where they are. If you hit show result files, these all get written out to this subfolder of the Linux file that we were looking at. This position file contains a lot of information about that, but the thing that you probably care the most about is this old Johnson service covers corrected. This is the PPK version of what we just did. So if we drag this in here, now we've got a corrected layer. Now we can display these, right? So create a point from the table. We just need to declare this coordinate system correctly. These are still NAD 83 2011, so we can find it. We've got a previous layer, but you can find it under the geographic coordinate system tree. We'll hit OK. We'll hit OK. It'll apply that projection, and now we get a sense of where we are with PPK. Remember that what we've taken here are floats and fixes, so you can generally expect these to be pretty substantially less accurate. I think that the original red points here are likely going to be more accurate here, but let's zoom in on the Google imagery and sort of see what we get. Again, the Google imagery is not definitive. I would consider this sort of a suggestive result more than anything, but in this case, I suspect that what we're seeing here is true. Our live RTK points are actually better in this case than the PPK points that we took, than the PPK analysis. Now, PPK is almost always going to be more accurate than RTK. This is one of the reasons why you might do it. But this is a rare case where it wasn't, and this is likely for a couple of reasons. One reason is that a lot of the points that we were taking were really right next to buildings and trees, so the quality isn't quite as good. I'm not sure in what case was the specific cause why the PPK was a little bit worse. If we wanted to, we could set that back to float, and we could rerun that, but you can see that none of our points actually were made it as fixes. Again, that's fairly unusual. Most of the time when you do this, they really all should come out, but this is a good reason why to do RTK if you can, and do follow up with PPK if you want to. That kind of concludes things. I guess a take-home message here is to remember that your projection, your coordinate system is going to be the same as whatever your CORS station is broadcasting in. So you will want to look that up. You might have to comb through the documentation on the website. In this case, I happen to know, because I've recently combed through that website, that NYBH is broadcasting its stuff in NAD 83 2011. And the vertical is actually the ellipsoid for that. So We'll wrap it up then. Thanks for listening, and we'll see you next time.